5.7, we're talking about inverse functions, inverse trig functions. Okay. And so we did this a little bit when we were looking for angles. Okay. The great skeptic is going to come in and call me out on my BS in just a moment. We're going to say that, and we've done this before, right? We've said that if I have the sine of theta, if y is equal to the sine of theta, I want to solve for theta. Okay. So theta, we would say, is the inverse sine of y, right? Theta is the inverse sine of y. The log is the power. The sine is the y coordinate. Cosine is the x coordinate. Inverse sine, what's inverse sine? It's a, say it again. What object is it? What's this called?
Theta.
And what is it? It's an angle. Inverse trig functions are angles. Inverse trig functions are angles. So that when I say the inverse sine of the square root of 3 over 2, oh my goodness, I'm looking for an angle. Okay? I'm looking for the angle that when I take the sine of that angle, I get the square root of 3 over 2. You get a circle! I'm looking for an angle that when I take the sine of that angle, I get the square root of 3 over 2. What angle is that? What angle do I take the sine of? Say it again.
60 degrees.
60 degrees is right. I prefer radians. It's
Pi
over 3. Questions about that? It's pi over 3. The inverse sine is an angle. Right? So it reverses, and this is true because the sine of pi over 3 is the square root of 3 over 2. We know what the inverse does. It just switches the x's and y's. We're just going the other way, right? We know the sine of pi over 3 is the square root of 3 over 2. So the inverse sine of the square root of 3 over 2 should be pi over 3. Now the great skeptic is coming and saying, hold up. Why is that pi over 3? Brother, if you look back to the circle. Go to 2 pi over 3. What's the sine of 2 pi over 3?
Also 3 pi over 2.
What's the sine of 2 pi over 3? What's the y coordinate? Square root of 3 over 2. Why is this not 2 pi over 3? Right? Why is it not 7 pi over 3? Right? So yeah, so why is it that it's this one and not one of the other ones? And that's a reasonable conclusion we need to make. We need to pick. Okay? So that when I look at this function, in other words, the great skeptic is saying, yo, you want to take an inverse of this? You want to take an inverse of this? Why can't I take the inverse of this? Does this pass the what test? If I want to switch the x's and y's, for each x there's only one y, for each y there's only one x. That's the other one, the horizontal line test. Does this pass the horizontal line test? If I draw a horizontal line, does it hit the graph only one time? Then how in the world can I talk about taking an inverse, right? This has no inverse, yet on your calculator it has sine to the -1, right? So I don't like this, right? So we know what to do here, right? We're gonna make it so that it only has an inverse, right? So I need to only look at part of the graph so that, and it's this part right here, I care about this. I want that. Does that pass the horizontal line test? Yes. This is the part of the sine graph that I'm going to use. Okay. So that now when I look at the square root of 3 over 2, it only comes from one thing. It only comes from one thing, right? So before, when I had the square root of 3 over 2, I had this thing, right? When I had y equals the square root of 3 over 2. Too many values. Too many values. Okay. And so now, if I choose to pick the function in the right way, I can choose it so that there's only one value that works. And that value is going to be pi over 3, right? Which is close to 1, which is a little bit more than 1, right? Which is right here, okay? It's that value, pi over 3. And it's only pi over 3. That's the only one that's going to give me the square root of 3 over 2, okay? So I'm about to define two new functions, and it's inverse sine and inverse cosine, okay? Now it's clear that I need to define them so that I can reverse them, right? So I'm only going to define them on a specific set of values, okay? What values are these? Well, I wanted to go from -1 to 1. What's this value over here? You know what value that is? Where's the sign -1? Where's the sign -1? Get our unit circle out. Say it again. Where's the sign -1? I'm talking about 3 pi over 2, right? Is that okay? But I have to tell you that this right here, this value down here, that value is not 3 pi over 2. 3 pi over 2 is like 4.5. So that's not 3 pi over 2. What is that? Instead of 3 pi over 2, we're going to say that it's going backwards. What angle is that? If this is pi over 2, this is negative pi over 2. Okay? So we like the sign. If we want to take an inverse of the sign, then we need to go from minus pi over 2 to pi over 2. That's the domain of the sign if we intend on taking an inverse. Okay. So the domain of sine is minus pi over 2 to pi over 2. Right. What's the range? Well, it gives us the full range. We already knew that the range of sine, it goes from -1 to 1. Okay. So at negative pi over 2, you get -1. At pi over 2, you get 1. And as you can see, you get every y coordinate in between. Right? So it fulfills the whole thing. And so therefore, if now I want to look at this new function, which is the inverse, what are we going to do with the domain and range? We're going to switch them. Right? So here's the definition. So then inverse sine of x, the domain is -1 to 1. You put in some number between -1 and 1, and you get out, here's the domain of that function, and you get out a number between minus pi over 2 and pi over 2. Okay. Questions there? Let's do some examples. Inverse sine of 1/2. What's the inverse sine of 1/2? Whatever answer you tell me better be between negative pi over 2 and pi over 2. So, let's write it in words. Let's write it in words. So the street version is, what angle has a y coordinate of 1/2? And specifically, what angle in the interval minus pi over 2 to pi over 2? The answer is pi over 6. Inverse sine of 1/2 is pi over 6. Now, we saw this kind of when we were solving for angles. We need inverse straight functions, right? I'm going to give you a triangle. Remember, we're trying to crush this triangle. Oh my goodness. I'm going to give you all 3 sides. All this time I've been saying I'm going to give you two sides and an angle. I'm going to give you two angles and a side. Sometimes I'm just going to give you all three sides and I'm going to ask you to give me all three angles, right? We know that if we're going to crest a triangle, then we're going to have to bring trig functions into this. I'm going to have the sine of an angle and I won't have any other angles, right? I'm going to have to do the inverse sine, okay? So that's why we have to talk about it. Because the inverse sine is an angle and sometimes you'll have a triangle, you won't have any of the angles but all the sides. Okay, good. So, pi over 6, right? Pi over 6 is the answer to this. Pi over 6 is in this interval. Let me try and trick you up now. Inverse sine of negative 1/2. Well, let's do negative square root of 3 over 2. Inverse sine of negative square root of 3 over 2. Say it again. Go ahead. Negative pi over 3. Right, so negative pi over 3 is here. Right, negative pi over 3. Let me go ahead and bring in the great skeptic. Hold up, the great skeptic says. She looks on the circle and sees, no, it's 5 pi over 3. What would we say to her? We've decided that we're only picking the answer here. Right? It is true that the sine of 5 pi over 3 is minus square root of 3 over 2, but we've decided that in picking the inverse for each y there's one x, for each x there's only one y, we need to decide which one it is, and we've decided that it's going to be this. Okay? So, and this is what the calculator does. The calculator is programmed to make sure that when you do inverse sine, it's always here. Okay. So it's not 5 pi over 3, it's negative pi over 3. So the street version is that when you're doing inverse sines, if you want this angle, you're going to look on the circle, look. You're going to look on the circle and you're going to see that it's 5 pi over 3. And then you're going to remember, yo, I can't put that in here because 5 pi over 3 is not in this interval. And so I just need to move backwards pi over 3 units. Okay. So you just need to do 2 pi minus that. It just gives you the angle in the fourth quadrant, but that fits that interval.
So the interval is only 3 and 4?
Yeah, the interval is only quadrants 1 and 4. Quadrants 1 and 4. That's right. That's exactly right. That one is negative pi over 3. Okay. Questions there? Let's do cosine. Cosine, of course, its graph merely shifting sine over has the same issue, but it's going to be defined on a different set. So let me offer to you, where should I make that so that it's 1-to-1? Right, so we choose over here, it's not so shocking that we choose 0 to pi, right? If the cosine is just the sine, I need to zoom in here, right? Yeah, so it's like this. Right, so it's there, right? If the cosine is the sine just shifted pi over 2 units to the right, then if sine was okay from minus pi over 2 to pi over 2, if I shift everything over pi over 2 units to the right, then you get 0 to pi. We'll just move everything over pi over 2 units to the right, 0 to pi. So cosine, if I want to take an inverse, it's going to exist on 0 to pi. And when I do inverse cosine, the angle has to be between 0 and pi. We'll summarize that. So for cosine, if I want to take an inverse, it can only exist on 0 to pi, and the range, of course, is minus 1 to 1, so that the inverse cosine should take some angle, some number between minus 1 and 1, and then it should return some angle from 0 to pi, right? So that means, as Joe was saying, sine exists in the fourth and first quadrants, cosine exists in the first 2 quadrants. Okay, so that when I think about inverse cosine of the square root of 3 over 2, I'm looking again for an angle. I need the angle whose cosine is the square root of 3 over 2. What angle is that? Say it again. Pi over 6 or 30 degrees for sure. We also need to be careful here with our calculators in, right? So when you do inverse, when you do inverse cosine or inverse sine, the calculator is going to give it to you in radians or degrees depending upon what your mode is at the time, right? So this could give you 30 degrees if you're in degrees. It might give you a decimal, right? It's not going to give you pi over 6. These TI-85s don't write pi over 6 for you as the answer. Go ahead. I thought you were going to ask. Okay. Let's do one that's funky. Inverse cosine of minus 1/2, or inverse cosine of negative square root of 2 over 2. This angle you're picking for which quadrant? It's from the second quadrant, right? This angle needs to be in the second quadrant. Go ahead.
Would that one be 2 pi over 3?
It is 2 pi over 3.
And the other one would be 3 pi over 4?
That is correct. All of these angles are from 0 to pi. All those angles are from 0 to pi. That's exactly right. Inverse cosine of negative 1?
1/8 or pi?
That's right. That's right. That's exactly right. Questions there about that?
Can you repeat what it was the 1 to 4 quadrant?
So yeah, you were saying that the inverse sine, your answer needs to be either in the fourth quadrant or the first quadrant. If you're taking the inverse sine of a negative number, the answer's in the fourth quadrant, and it's got to be the negative angle. That's right. If you're taking the inverse sine of a positive number, the answer's in the first quadrant. The inverse cosine of a positive number, the answer's in the first quadrant. The inverse cosine of a negative number, the answer's in the second quadrant. I think this is going to allow us to burn through a lot of the homework. Let's get started. More practice is good practice here. Homework here. It's 5.7. It's right here. Inverse sine of 1/2. It's all circle. You just get the circle out. Pi over 3. Questions? This is just all circle. They want all the answers in radians, by the way. They don't want anything in degrees at this point. Inverse sine of negative 1/2 needs to be in the fourth quadrant.
2 pi over 3?
No.
It's not.
It's in the fourth quadrant.
Oh, snap. Oh, 4 pi over 3?
Right. No.
Negative pi over 6.
Negative power over 6. All right, let's rectify this for you. Okay, so that's a great question. So you go in the circle, right?
Yes.
The answer has to be here.
Oh.
Right, so it's either, as you know what I'm saying, it's the fourth quadrant or the first quadrant. So you need to find where the y coordinate is negative 1/2. That's this one, right?
Oh, yeah.
11 pi over 6, but again, 11 pi over 6 doesn't fit.
So we pi over
Negative pi over 6. Other questions on that? Anyone wants me to put up the unit circle and explain that?
Sure.
Yes, okay, thank you. So let's get a unit circle. We're talking about this one here. So great, I don't even need degrees right now. So then we're talking about inverse sine of, was it negative 1/2? So inverse sine of negative 1/2. The inverse sine only lives here. Okay, so inverse sine of negative 1/2. I'm looking for the angle whose y coordinate is negative 1/2. It's this angle. We're tempted to say it's 11 pi over 6, but we can't do that because you need to take, the answer has to be between negative pi over 2 and pi over 2. So it's not 11 pi over 6, it's negative pi over 6. It's negative pi over 6.
But wouldn't that be like, you said it gotta be between negative pi over 2 to pi over 2?
Yeah, negative pi over 6 is between minus pi over 2 to pi over 2. Negative pi over 6 is small, it's less than pi over 2, but it's negative, so it's reversed.
Okay.
Yeah, go ahead.
Quick question. So the first one I thought was pi over 6.
What do you mean the first one?
First question.
What was the first question?
Sine inverse of 1/2.
Sine inverse of 1/2 is pi over 6, yes.
Okay, we put pi over 3, it doubted.
Oh, did we? I'm sorry.
All right.
Where?
You did?
Where did we do that?
Should be at 5.7.
Yeah, 5.7 one word.
Oh, let's see here. I'm sorry. Oh, I'm sorry. Yeah, it's pi over 6. Thank you.
All right.
Yeah, thank you.
Thought I lost on the translation.
No, just stop me there. Yeah, no, it's pi over 6. Yeah. Okay, other questions about this? Why it's minus pi over 6, not 11 pi over 6? The answer, we decided to put it in that interval. I'm sorry.
You go ahead.
All right, inverse cosine of minus square root of 2 over 2. Go to the circle.
3 pi over 4.
Inverse cosine is this here, right?
Yes, sir.
3 pi over 4. So inverse cosines live in the first and second quadrants. Okay, excellent.
So this should be pi over 4 or 3 pi over 4?
That's a great question. So it is one of those two, but it's cosine inverse of negative square root of 2 over 2. So the x coordinate is negative. That's why it's the second quadrant. And that's why it's 3 pi over 4. Right. What angle gives me an x coordinate of 3 pi over 4? Okay. Inverse tangent. I haven't mentioned this, but inverse tangent x lives also on minus pi over 2 to pi over 2. Okay. So. Right, so that's the range. The domain is minus infinity to infinity. I can put whatever number I want into the inverse tangent. The domain's minus infinity to infinity. The range is minus pi over 2 to pi over 2. And these are open and not closed. These are open. Okay. Square root of 3 over 3 might seem a little funky. The tangent of what angle is the square root of 3 over 3? Do you know? We only need to see this once. This is 1/2 over the square root of 3 over 2. Okay. And so this is, just remember, that's the y coordinate over the x coordinate. Right. Pi over
6.
Right, pi over 6. So once you just see that this is 1/2 over the square root of 3 over 2, then you know that the y coordinate has to be 1/2, and that means that it's pi over 6. That's the other one. Inverse tangent of the square root of 3 is inverse tangent of the square root of 3 over 2 over 1/2. Right? Pi over 3. So those are funky. So these are ones that you probably just want to memorize. That we're just talking about If you did the tangent of the power of 3, you would get the square root of 3, right? Because it's just the square root of 3 over 2 over 1/2. Let's get our calculators out. Type your answer in radians. We just need to do this one time, just to make sure we're breathing. Find the inverse trig function button. Inverse sign, so you need to press second, and then sign, and then put in 0.2, round to 2 decimal places. What do we get?
1.2.
I'm worried that you're not in radians. What'd you get?
0.2.
0.20. Oh no, yeah, and I actually don't know how to change the radians of this.
What kind is that?
Oh, it's mode. Its mode is right here.
Oh, yeah.
No, I still don't know.
It's shift mode. If that's this one.
Oh, really? Let me see.
Is it-
Yeah, shift mode?
Yeah.
Oh, yes, it is shift mode. So if you do shift mode, then you can change it to radians by pressing 4. And now it's in radians. And then you do an inverse sine of 0.2. And you get that. Yeah. But that also does, mode is easier, right? You just put in, make your radians and then do it. Yeah. So it was what? 20 to the nearest 100, 0.20. Excellent. Inverse sine of negative 0.14. Inverse sine of negative 0.14. Everything's in radians. What do we get there? Say it again. Negative 0.14. That's good. Inverse tangent of negative 24.
Negative 1.52. 1.53.
Is that what you?
Negative 1.53.
Negative 1.53. We agree on that? I'm trusting you. I have no idea what these things are. I had the honor of doing the pre-calculus class before this one. I was covering for one of my colleagues. That pre-calculus class, they started on log. They're still doing logs and stuff. I was like, what's wrong with you guys, right? And so we were talking about, they still had a little bit of confusion about the natural log and each of the x being inverses and how they cancel, right? So they cancel because they're inverses. Number 9, sine and inverse sine should cancel. What's the answer? 0.4.
Right.
They just flat out cancel. And you can test that, right? You can put in sine inverse of 0.4 and then take the sine of it. They should flat out cancel and you get 0.4, right? This is exactly what we mean by them being inverses, right? They absolutely, sine inverse is going to transform 0.4 to some other decimal. Sine is going to come along and redo whatever the damage sine inverse did to it. That's exactly what the inverse means. 0.4. Sine inverse of the sine of pi. They're trying to trick us. Oh no. Oh yes, I know. Trying to trick you. Oh, we can do it right here. What am I doing? Where was I going to copy that to, right? I'm already in the document. Sine inverse of the sine of pi. It doesn't work that way. What's the sine of pi?
3.
What's the sine of pi?
Oh.
0.
0. What's inverse sine of 0?
0.
It is 0.
So the answer is 0?
The answer is 0.
Wow.
You see the difference? Because why couldn't I have said that this was pi? Because pi is not between negative pi over 2 and pi over 2. Right? So your answer, when you do the inverse sign, has to be between negative pi over 2 and pi over 2. Okay? So the sine of pi is 0. So pi takes sine to 0, but then inverse sine takes 0 back to 0.
But the next one is between.
So here, inverse tangent of the tangent of minus pi over 6 is going to be
6, because it's
negative pi over 6. That's right. That's right. It's going to get it. That's perfectly okay. Right. So this answer is between minus pi over 2 and pi over 2. Excellent. I think you've got it. So anyway, so we see the difference between this and this. Pi was not in the right interval. This one is in the interval. So the street version is, if you're in the interval, just cancel them out and you get the answer. If you're not in the interval, like pi is not in the interval minus power 2 to the power 2, then you need to go ahead and evaluate what that is and then take the inverse sign. Good. Rolling along. Inverse tangent of the tangent of 2 pi over 3. What's the tangent of 2 pi over 3? Right. We need the y-coordinate. So first of all, 2 pi over 3 is not in the interval, right? So we just need to evaluate what the 2 pi over 3 is. So tangent of 2 pi over 3 is the y-coordinate over the x-coordinate. We're in the second quadrant, so tangent 2 pi over 3, square root of 3 over 2 over 1/2, negative 1/2, minus the square root of 3. Inverse tangent of negative the square root of 3, and I need it to be in the interval minus power 2 to power 2. I need it on the interval. No, it's negative.
So negative pi over 3?
Negative pi over 3. All right, so again, it's just all the circle. The street version, if you can see it, is that, look, this is 2 pi over 3. The answer's got to be something over 3. Right? So the answer is either pi over 3 or it's negative pi over 3. And now all we need to do is check the sign. Yeah. And so this, because this is in the second quadrant, the tangent of this is going to be negative, and so that's why it's negative pi over 3. Right? So that's the easy shortcut way. So again, I knew that one was going to be pi over 6, and I knew it was going to be negative pi over 6 because that was going to be negative here. I know this one is going to be pi over 3, and I know it's negative pi over 3 because the sign of this is negative.
Can we memorize those? Like, can you memorize that? Like, that tangent on 12?
But the tangent of 2 pi over 3
Yeah.
is the square root of 3?
Yeah.
Yeah, sure you remember that, yeah. Sine of inverse sine of pi.
Still 0.
No. Undefined for sure. Why?
Because pi is outside of the pi over 2, negative pi over 2.
Now that's close. What's the domain of inverse sine? You can only put negative 1 to 1. You can only put numbers between negative 1 and 1 inside the inverse sine. Pi is 3.14159. So that's undefined. So that's good. So people are so apt to go ahead and blindly just cancel out, right? You got to make sure that the thing I'm writing makes sense. So, who do I have in here who's going to be in Calc 2? Any Calc 2 people? Got to go that way? One person? What were you doing again?
What's my major?
Yeah.
Chemistry.
Oh yeah, Chemistry Calc 2. Anybody else? So we'll need this for Calc 2. So what we're doing, trig substitution in integration. Okay, so I want to know the cosine of the inverse sine of 3 over 5. Okay, I wonder what the calculator does. Let's put this in. We're going to do this by hand. Please out. So the cosine of the inverse sine of 3 over 5, let's see what it says. Do it again. 0.8, and let's make that a fraction. What's 0.8? Math, interval, 4 over 5, okay? So the calculator does this for you, so it's nice, okay? So in Calc 2, we'll ask you to do this stuff by hand. We're going to do it by hand in just a second and see why this is 4 over 5. Let's do it now.
You can just write it.
Say it again?
You can just write it there, right?
You could put 0.4 over 5 right there.
No, you can just write it on the document.
I almost want it its own page because I got a lot to write. to do this. Yeah. All right, so then, all right, so what's inverse sine again? It's what object is it? Inverse sine is begins with an A. Okay, good. So when I write sine of an angle is y, right? Theta is the inverse sine of y. What's the inverse sine? It's what's that?
Angle.
It's an angle. Inverse trig functions are angles. Okay, they're angles. So when I say, what is the cosine of this angle, then I'm talking about, so I'm going to let theta be this angle, right? So theta is the inverse sine of 3 over 5, and I'm looking for the cosine of it. Now, if I'm saying that theta is the inverse sine of 3 over 5, right? What does that mean about the sine of theta? What's the sine of theta? It's what? I move the sign on this side, so what's left? 3 over 5, right? So whatever this angle is, I know that the sine of it is 3 over 5, and that is screaming a triangle to me. Right? So can we draw this triangle? And this is why it says sketch. Right angle. Here's the right angle. Here's theta. Can you tell me what this side is right here? 3. What's this? 5. Questions? Why is that? Because the sine is the opposite over the hypotenuse. So whatever angle this is, the sine is the opposite over the hypotenuse. Can we find this missing side? 3 blank 5 triangle. What's the blank? It's, what is it? What number is it? 4. Thank you, brother. 3, 4, 5 triangle. If we don't know what it is, we can use the Pythagorean theorem, but this particular triangle comes up so often that we should have this memorized by now. But let's get it. Z squared plus 3 squared equals 5 squared. Z squared plus 9 equals 25. Z squared equals 16. Z is equal to 4 or negative 4, but because we're talking about the length of a triangle, we're taking the positive. I'll never do that again. 3, 4, 5 triangle, right? 6, 8. 3, 4, 5, 6, 8, 10 triangle, right? So if you come across a right triangle that has 6 and 8, it's just a magnification of this one by 2. Okay. 5, 12, 13 is also another one. Knowing these triangles just saves you the time of having to do that. 7, 24, 25 is another one, I think. All right. So, what's the cosine of that angle? 4 over 5. That's the game. Adjacent over hypotenuse. It's 4 over 5. Okay. So if you want to find the cosine of an inverse trig of something, then you make this an angle, look at the triangle that that angle is implying, and then take the cosine of that thing. So now I could take the tangent of the inverse sine of 3 over 5. What would that be? What's the tangent of this angle? Opposite over adjacent, 3 over 4. Yeah. Let's see how bad this gets. I'm sorry, I was in here. Okay. So we're here. All right, try this one. Oh, there's that 5, 13. 5, 12, 13. That's another triangle. Okay. All right, so they want the tangent of this thing. Tangent of the inverse sine of negative 5 over 13. Tangent of inverse sine of negative 5 over 13. So now we're trying to figure out the sine of this thing. So the angle is inverse sine of minus 5 over 13, right? Okay. So the sine of the angle is negative 5 over 13. Is that okay? What do we know about this angle, by the way? What quadrant is this angle in? What is it? It's in the fourth quadrant. This angle's in the fourth quadrant. We'll keep that in mind. Theta is in the fourth quadrant. Okay. And so we're going to draw this triangle nicely. That's not so nice, but it's okay. That's a right angle in some universe. Here's the angle. Sine is opposite over hypotenuse. Okay, again, that's supposed to be 12. We'll do it one time. Z squared plus 5 squared equals 13 squared. Z squared plus 25 equals 169. Z squared equals 144. Z is equal to 12 or negative 12, but because we're talking about the side of a triangle, it's the positive. I now want the tangent of this angle. The tangent of this angle is then going to be, oh, so this is 12, right? The tangent of this angle is opposite over adjacent. And now the only thing that I've done here, so what I have done is I have removed all these signs from the triangle and just done the triangle. Now I have to come back and pay for the signs. This angle is in the fourth quadrant, so its tangent is negative. It's negative 5 over 12.
I got a question, Professor.
Yeah.
I think I forgot. How do you tell which quadrant it is? Like off the top of it?
That's a great question. So when we were doing inverse sines, right, it was either the first or the fourth quadrant. But all the negative stuff came from the fourth quadrant. All right. So, yeah. So I knew that angle was in the fourth quadrant because inverse sine comes from the first or the fourth. Great, 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 great. Great. Secant of inverse sine of negative 5 over 8. So I'm going to get a just a game plan for these. Secant of inverse sine of negative 5 over 8. Okay, so now we're going to have some square roots all over the place. I'm not afraid of those. Right, so then the first step is form a triangle. Right, so I guess the step 0 is actually to let theta be the angle inverse sine of negative 5 over 8. Right, this means that the sine of this angle is negative 5 over 8, and in particular, we take note that theta is in the fourth quadrant. Okay. So then we form a triangle, right? And we can drop the signs for the moment because we'll deal with that at the end. We're talking about theta. Sine is then 5 over 8, and we're looking for this, and this is not pretty at all. Okay. We're talking about 64 minus 25, 39. Square root of 39. Let's do it. Z squared plus 5 squared equals 8 squared. Z squared plus 25 equals 64. Z squared equals 64 minus 25, 39. Z is equal to plus or minus the square root of 39, and it's the side of a triangle. So it's the positive. Anything about that? That gets you all the signs. I need the secant. The secant is 1 over the cosine, so take the cosine and just flip it. This is a very funky square root of 39. And so I need the cosine. Let's get more space. I don't do that. Wait, where'd you go? Oh, it's here, I think. Yeah. So I need the cosine of this angle is, or we can just do the secant, right? The secant of this angle is adjacent, I'm sorry, is hypotenuse over adjacent, right? So it's 8 over the square root of 39. You just flip whatever the cosine is, right? So cosine is adjacent over hypotenuse, so hypotenuse over adjacent. We're pretty much experts in this now, right? 8 over 39. All right, so when you have a trig function on an inverse trig function of something, create the triangle, get all the sides, and we need to check the sign. Theta's in the fourth quadrant. What's secant in the fourth quadrant? Positive, right? Cosine in the fourth quadrant is positive. Secant is 1 over that, and that stays positive, right? So it's the plus. Just checking the sign. So yeah, just be careful when you're working through these about your signs. Sometimes you might forget at the end that it's, which quadrant you're in, right? So, excellent. Not there. Here. 5, 7. All right. So this is for sure Calc 2 stuff. All right. So then tangent of inverse cosine of 2x.
Could you put it in the calculator?
Nope.
Wow.
Right. So what is that function? Right, so all we're doing now, same steps. So the angle is inverse cosine of 2x. So that means that the cosine of the angle is 2x. And for the purposes, so for the purposes of writing a triangle, we want to make this a fraction. And we make it 2x over 1. So cosine of theta is 2x, and then we make it 2x over 1, and that will help us draw a triangle. Cosine of theta is 2x over 1. That implies a triangle where the hypotenuse is 1, and which side is 2x? The adjacent. That means we need to find this side. Call it z. Pythagorean theorem, 2x squared plus z squared equals 1 squared. And once we get that side, then we'll just take the tangent of it. 2x squared, you need to square everything. 4x squared plus z squared equals 1. Z squared equals 1 minus 4x squared. Z is equal to plus or minus the square root of 1 minus 4x squared. I don't think there's any questions about these steps. Square root of 4, square root of x, move it to the right hand side, take the square root of both sides.
So we could subtract 1 minus 4x squared?
No, that's it. They're not like terms. It just stays like that. So that side is the square root of 1 minus 4x squared. What's the tangent of that angle? Opposite over adjacent. Opposite over adjacent. That's right. We're rolling towards the end. I also had the honor of covering again cosine of inverse sine of 9 over x. Again, that's just another triangle. You do enough of these, you'll just be able to read off this triangle. Can someone tell me what this triangle looks like now? What's the hypotenuse? X. What's the opposite? 9. Questions? I'll go through that carefully. Theta is inverse sine of 9 over x. That means that the sine of theta is 9 over x. That means it's the opposite over the hypotenuse, and that creates that triangle, right? We want to find the adjacent because we want to know what cosine is. Can anyone read off what that's going to be? Okay, you'll do it soon enough. Z squared plus 9 squared equals x squared. Z squared plus 81 equals x squared. Z squared equals x squared minus 81. Z equals plus or minus the square root of x squared minus 81. And of course, we're taking the plus. X squared minus 81. I want to know the cosine of this angle. It's adjacent over hypotenuse. Okay. Questions there? So I'll pause that there. Technically, what I'm